Hello, my name is Bill Metcalf, and I'm with Global Process Automation. In this webinar, we will be using Capstone's DataPark product to look at automated OEE and root cause tracking. OEE is defined as operational equipment effectiveness. This is used to track non-production items such as time loss, speed loss, or quality losses. Time losses are broken into two categories: unscheduled time and unplanned downtime. Unscheduled time can be anything from lack of customer orders or any time when the machine is not planned to run. Unplanned downtime is any time that the machine is scheduled to run and is not running. This may include mechanical breakdowns, it may include product or grade changeovers. Speed losses take into consideration reduction in production speed and minor stops. Quality losses take into consideration startup and shutdown defects, scrap rework, or any product that does not meet the quality and needs additional processing. Once we've identified these key variables, the OEE calculation then is simply availability times performance times quality. The availability portion of our calculation. To determine the availability, we must first decide what period of time we're actually going to be reporting OEE for. This is typically done on a per hour or per shift basis. Unscheduled time is the dynamic variable in our calculation that takes into account planned outages. These can include downtime, lack of customer orders, or any time that the production facility is not running normal operations. Unscheduled time typically enters into the equation either from a tag configured from the MES planning system, or it can be handled through the use of an MDE or operator input. The unplanned downtime variable in our calculation is typically taken from the control system and is an indication that the process is running. It may be necessary to use the script builder to build a calculation that says if the machine speed is greater than this, or if a specific flow rate or temperature is greater than a certain level, we consider the operation is running and count the time as running accordingly in our calculation. Once we have the actual running state of the equipment, we can take the inverse and consider that is unplanned downtime. From there, we have the three variables that we need to complete our availability calculation. Availability equals unplanned downtime divided by the total time minus the unscheduled time. As I said at the beginning of this webinar, the topic is automated OEE and downtime tracking. Although OEE and downtime tracking are two different disciplines, there is some overlap and we can take advantage of that opportunity. Since we have already defined what our running state of our equipment is, we can use this as a trigger so that we can add context to why the machine is not running. Downtime tracking can be used in preventative maintenance planning. By capturing any time that the machine is in a non-running state, we're able to quantify this by duration and type of outage. Showing a Pareto chart over, say, the last 30 days, we can easily see where habitual bottlenecks and stops occur. If we add operator input to our downtime tracking, we can easily use this to train operators in best practices during specific events. We can also use the downtime event to trigger quality control measures. We may want to increase the testing frequency during a shutdown or unplanned stop of a machine, or maybe increase the testing frequency as we come up from an unplanned event, all of which leads to overall equipment optimization. Park's alarm and event is the perfect fit for an out-of-the-box solution. By placing our trigger tag that indicates whether or not the machine is running or not into a trend and enabling the alarm and events, we can easily track when the machine is running and when the machine is not running. Additionally, using the alarm and events, we have created events for those durations as shown in the trend. The operator can simply select on the red segment of the alarm bar. We can pull up the information about the event. Dialog, we can see that we have captured the start time and the end time of the event. Additionally, we've captured the process area. We have a place to set our reason code, or the reason why that event occurred, and we can get input directly from the operator through the text entry of comments. PCS and PLC systems, which contain first out logic, we can use that logic to automatically populate the reason code to these events. Advanced features, we can also filter which events require operator input. We can also associate process information around the process at the time of the downtime. We can also include things like the site SSM plan, so that as they come back up from a downtime event, we can actually have procedures that they need to follow to bring the production back online. Here's an example of a typical operator screen. You can see that we display the first out information to them, showing all of the events that have taken place, their reason codes, and their durations. Additionally, we have buttons that allow the operator to interact. When buttons are red, that is an indication that there is an unanswered event. The number to the right is an indication of how many events have been unanswered. For the operator to interact with this, they simply click on the red button, which brings up the dialog block, allowing them to fill in the information about the specific event. Now that we have accounted for all of our running time or lack of running time and applied context to our non-running events, let's get back to the OEE calculation. The next portion to look at in our OEE calculation is the performance of the machine. Are we running at the desired production rate, or at some rate less than what is expected? Machine performance is determined by taking the actual units divided by the target units. The actual units is that unit of measurement that is used for production, whether that be tons per day, gallons per minute, or a speed. This is the unit of measurement that you're using to judge your production. The target units is usually set by the manufacturer. A piece of equipment typically will come with a rating to produce X amount of production per day. This is what we will use for our target. Example, we have a target speed of 550 meters per minute, and we can see that for day shift we had an average speed of 361 meters per minute. So that gives us an effective target percentage of 65%. Since we're already gathering this data, we can also generate some additional KPIs. Since we know the amount of time that the unit has been running during a shift, we can take that time divided by the total time of the shift, and we can come up with KPIs such as the percentage of time that a piece of equipment has been running during a specific shift or during a specific period. When assessing the performance in a line that is composed of multiple pieces of equipment, it is important to select the piece of equipment with the lowest target production rate, so that you ensure that you get an accurate performance rating for your production line. Quality is the final piece in our OEE equation. Quality is the number of good units divided by the actual units produced. This information can come from real-time inspection systems, from LIMS systems, or it can be a manual data entry. Essentially, any bad units are going to be subtracted from the total amount of units produced to give us a final production number. In summary, our OEE calculation is the availability times performance times quality. With the OEE calculation complete, we can now display this in dashboards in reporting. Here's an example of a typical dashboard. Notice in the dashboard that not only are we showing the OEE, but we're showing some of the other results that were used in creating our OEE. We're showing the percent running for a specific piece of equipment, and of course the inverse of that is the downtime. Since we are tracking when the machine is not running, and assigning reason codes to that or to the specific pieces of equipment within the line. We're also showing the number of downtime events, and we're showing the context of the event, why the machine was down for such an extended period of time. In addition to adding OEE to our dashboards, we can also add them to reporting. In addition to OEE reporting, we now generate reports based on downtime. I hope that you found this webinar informative. If you'd like to learn more about Global Process Automation, who we are and what we do, here's our contact information.